JEE 2025 Advanced, Paper 1, Question 1, Polynomials and Coefficient Comparison. This problem gives you 6 unknown constants and asks for one specific coefficient. Most students start expanding blindly and drown in algebra. But there is a beautiful shortcut hiding inside the condition f of x is not equal to g of x. Let me show you. Okay, let us understand what we need. H of x equals f of x plus 1 minus g of x plus 2. We need the coefficient of x cubed in h of x. So our plan is simple. Step 1, expand f of x plus 1, collect the x cubed terms. Step 2, expand g of x plus 2, collect the x cubed terms. Step 3, subtract. But here's the catch. The answer will contain a3 minus b3, and we do not know those values. That is where the condition f of x not equal to g of x saves us. Let us start with f of x plus 1. Replace every x in f of x with x plus 1. The x to the fourth term becomes x plus 1 to the fourth. By binomial expansion, that is x to the fourth plus 4x cubed plus 6x squared plus 4x plus 1. The a3 times x cubed term becomes a3 times x plus 1 cubed. That gives a a3 times x cubed plus 3x squared plus 3x plus 1. Now we only care about the x cubed coefficient. From x plus 1 to the fourth, we get 4. From a3 times x plus 1 cubed, we get a3. The lower degree terms in f cannot produce x cubed, so the coefficient of x cubed in f of x plus 1 is 4 plus a3. Now g of x plus 2. Same idea. Replace x with x plus 2. The x to the fourth term becomes x plus 2 to the fourth. Expanding, x to the fourth plus 8x cubed plus 24x squared plus 32x plus 16. The b3 times x cubed term becomes b3 times x plus 2 cubed. That is b3 times x cubed plus 6x squared plus 12x plus 8. Again, only the x cubed contributions matter. From x plus 2 to the fourth, we get 8. From b3 times x plus 2 cubed, we get b3. So the coefficient of x cubed in g of x plus 2 is 8 plus b3. Now subtract. The coefficient of x cubed in h of x equals 4 plus a3 minus 8 plus b3. That simplifies to a3 minus b3 minus 4. So the answer depends on a3 minus b3. Most students get stuck here. They think we do not know a3 or b3. How can we find the answer? But remember, we have not used the most important condition yet. F of x is not equal to g of x for every real x. This is where the problem actually breaks open. Let us compute f of x minus g of x directly. F of x minus g of x equals a1 minus b1 plus 10 minus 3 times x plus a2 minus b2 times x squared plus a3 minus b3 times x cubed. The x to the fourth terms cancel because both have leading coefficient 1. So f of x minus g of x is at most a degree 3 polynomial. Now the key observation. The problem says f of x is not equal to g of x for every real x. That means f of x minus g of x is never 0. This polynomial never crosses the x-axis. But think about this. If a3 minus b3 is not 0, then f of x minus g of x is a cubic polynomial, a cubic. And here's the fact every JEE student must know. An odd degree polynomial always crosses the x-axis. It goes from minus infinity to plus infinity, or the other way around. It must have at least one real root. So if this polynomial never equals 0, it cannot be a cubic. Therefore, a3 minus b3 must equal 0. So a3 equals b3. Plugging back in, the coefficient of x cubed in h of x equals 0 minus 4, that is minus 4. Let us do a quick sanity check. With a3 equal to b3, f of x minus g of x becomes a quadratic plus 7x plus a constant. For this to never be 0, the quadratic must have a negative discriminant. The coefficient of x is 7, which is non-zero, so we need a2 not equal to b2, and 49 minus 4 times a2 minus b2 times a1 minus b1 less than 0. That is achievable. The problem is consistent. The answer is option C, minus 4.
The takeaway: whenever a JEE problem gives you a condition that a polynomial is never 0, check its degree. Odd degree polynomials always have a real root. So a never 0 polynomial must have even degree. This one fact forced a3 to equal b3, and the entire problem collapsed to simple arithmetic. This saves you 5 minutes of pointless expansion in the exam. Follow at Superschool IIT JEE for daily JEE solutions, one problem at a time.